All right, we're going to talk about adding vector components today, and this help introduce more of the IJ and eventually K when we get to three-dimensional stuff. But we'll start with this simply as, let's do, get a ruler in here and get ourselves a 90-degree axis and a x-axis, a 90-degree axis, y-axis and x-axis. All right, now I'll put them in blue. We're going to put a vector over here. We'll call this one P, and I'm going to call another one over here in quadrant 2 as Q. Okay. And off that, we're going to be able to find the x and y components. All right, and we have a particle that is in the center here, and we'll give that a O designation for the origin. Let's make that a little neater. O for origin. And what we're going to be looking for is these. I'm going to draw them in red, and we'll label them, and then I'm going to show you the math, or not the math, but the general theory behind it, and then we'll do a real problem with some numbers here so you can see it. All right, and I'm going to cheat this one a little to the right of this axis because I want to use the other side for the other one. There we go. And this will be P X, and I'm going to put an I on it, and this one's going to be P Y, and I'm going to put a J on it. Okay, so remember that's our vector notation. And then when I do Q, let's get back here. When I do Q, I'm going to do this one, and that'll be Q, Y, J, and then I'm going to do a one in the x-axis, which will be this way, and that one will be Q, X, I. Okay, so those are the components. Ideally, we'd know the value of P, we'd know the angle between this to solve for the components, but right now it's just a matter of keeping it general. All right, let's go back to a black pen, and what I want to do is this. We're going to take a look at how we're going to do this. So we're going to add these together, but we're going to look at R is equal to, the resultant of these two vectors is equal to P plus Q. Okay, and that'll give us where things are going and help us define what's the resultant vector of P and Q. Ideally, if I was to guess, it's probably someplace up in there is where we'll terminate a well, actually be a little higher than that, but it'll be in that portion of the quadrant up in here someplace that we terminate at. You can do this with the parallelogram law or the triangle rule to get up to there, but mathematically it's going to be faster and easier to think of it this way. Okay, so here's how we're going to do this. We need to know what is the resultant x in the y plus the resultant y in the j. Okay, and that means that we're going to be looking at p xi plus p yj plus q xi plus q yj. Sure I got those all right. Yep. Okay. So really I just expanded upon this down to here and we should be good. Now, just as in all things algebra, we want to bring the x's to one set and the y's to the other. In this case, we're going to bring all the i's and the j's together. So I'm going to rewrite this as pxi plus qxi, and we're going to group that. And I'm going to do the next with, pyj plus qyj. Put a parenthesis around those. Okay, and that is the simple part of all that. Okay, so easy, but some of the basics of this thing is really just identifying what the components are of the vector p and the vector q, and then adding them together to figure out what our final vector would look like, or the resultant vector would be. So far that's pretty straightforward math. We didn't do anything strange or complex here. Boy, I can't talk today. All right, so let's do a couple little rules here, or not rules, but steps in helping you to sort this out. So steps 1 would be resolve boy, I can't spell today. P-O-N-E-N-T. Resolve component vectors. Okay, and basically what we're looking for is, let's pick on P for a minute. This is the xi plus pyj. Okay, or the q, whatever that is. Basically, that's what we're doing. Okay, and then do yourself a favor up here in your free body diagram. Draw them in so you can see it. Okay. Step 2, add the x and y together to find r. Okay, and once we find r, and that's probably an r with a triangle or a line over top, and we will know where that is. Okay, and these should be, this all show up here. I'm getting a little sloppy in my notation. My apologies. All right, so once we do that, we're good. And then the last bit is once you get the R components, 3, use I'm going to write this out. That's a J. Let's make it a J. Okay. And those are the steps you need to do this. Now that seems fairly simple and not horrible, but let's take a look at it and see if we can find one of these that we really like to do. Okay, and I'm going to pick you a Beer and Johnson problem that's a favorite. So again, if you haven't realized, I'm using Beer and Johnson's books for this, but any book on statics will actually help you with this. All right, so let's do an example here. Get a ruler. All right, I'm going to draw here. If you haven't gotten yourself a nice ruler yet, you probably do want to get one for statics, because it'll come in handy when you do strengths and that sort of stuff. Go away. Go away. Nuts. I was going to get it lined up, but we'll do that. Okay. So I got an x-axis here. I got a y-axis there. We're going to keep this two-dimensional, but we're going to have three vectors we're going to try and find the components for. Okay. So let's do this one. Get yourself on the line. And the angles aren't important when I draw these. It's more the value. Okay. And we're going to call this one A, and that's going to have a magnitude of 800 newtons. And if I take the other one and we drop it something like so, and we give that one a B, and we define that as 424 newtons. Okay, and then just to have the third one in here, we'll put it in here like so. And I'm trying to keep these angles from being something convenient, because the angles aren't really important at this point. It's going to be based on the values we give it for solving some of this stuff. And you'll see this in a second. So we're going to call this one C, 408 newtons. All right. And just to be a good steward of using the Beer and Johnson book, this is example, not example, this is problem 2.23 from 2013. And it's okay. Just so you know where the problem came from. It's always good to let everybody know where you're getting them from. All right. So literally we need to do this, and I'm going to change colors here for a minute. So we're interested in this. We're going to be interested in this and that one. Okay, and then we're interested in what goes on in the Y, and this and this. And the last one is over here. And once we find those pieces, then we'll know what the whole system is looking at. So this one is, if I did it down here, would be the A sub x in the I, and we can go from there. Okay. So keep that in mind, and let's do some math here. All right. So first thing, I need an origin. That would be kind of useful. And I want to go back to black pen. All right. So I got an origin, and I'm looking for O to A is 800 newtons, and I'm going to find its um, components. All right, and what's missing? I'm missing some things here. Oh, yeah, I didn't give you these things, did I? Okay, let's back up. So it'd be useful to tell you this is 600, and this is 800. Okay, I'm doing this problem completely wrong. Sorry, folks. Um, these I don't know. We're looking for those. Okay, so this is 600 newtons this way. This is 800 newtons this way. All right, this one down here is 900. This is 900. This one here, and I'll do them inside here, is 450 and then 560. 450 newtons, and this is 560 newtons. And there's a newton there. Okay, so this particular problem, they're going to give us the components. We have to figure out what the vector A, B, and C are. Okay, cool. Sorry to get that all confused. And I guess we probably should write a statement here. Find the vectors of A, B, and C. Okay, and that'll help us. I'm just taking a look at the problem here, making sure I didn't miss something else in this that I should have told you. Pause for a second here, folks. There's something a little screwy in this problem. I want to sort it out. All right. So this is the screwy part. These are in millimeters. I'm getting my newtons and millimeters all confused. So you won't be alone in this. If you ever think people don't make mistakes as engineers, we do. And we try not to, but you need to be careful. Okay, there. And now I do know these, but what I don't know is the vector components. So I know A is 800 newtons. I know C is 408. And I know B to be 424. Okay. All right. Think I got my stuff documented well enough here. X, Y, Z. I got O as the origin. We got our distances. Cool. We can now start looking for the vectors. All right. And find the vectors of A, B, and C, which I wrote wrong. So we're finding the component vectors, components of A, B, and C. Alright, and then we'll have ourselves in a good direction. Okay, alright, so now let's do some basic stuff. We know that OA is the hypotenuse or the vector of A, and we're looking for the components x and y. So if we take a look at this, let's do this in green. If we take a look at this triangle in here, then we can see that we'll know the distances, and we can help that find what the distance is of AO. So we're looking for the distance of AO. Oh, back to black, please. And that's going to be equal to the square root of, and I'm going to write this down as 800 millimeters. We're going to square that, plus 600 millimeters, and we're going to square that. Okay, and that will leave us a number that is equal to, when we do this all out, 1,000. Okay, so everybody's good so far. So our distance along here is 1,000 millimeters. Okay, and we know we got a vector magnitude of 800 newtons. So now we got a distance and we got a magnitude that we know. Okay, well, let's go find, let's do AOB next. Let's do OB next. All right, and that's going to be the 900 meters squared plus the 560 meters squared. And if you do the math with that, and I encourage you to check the math, get a calculator out here and figure it out, we're going to be that. Okay, and then OC, the distance of OC will be square root of 450 millimeters squared plus 900 millimeters squared. And that should give us a answer that is 1,020 millimeters. Okay, if you're fanatic, and I don't mean that to be mean, but OA is always going to be the OA of the X plus OA of the Y, and you're going to square those, take the square root of them. Okay, or if you're really going to have some fun, it is OA X. Oh, that's not that's supposed to be an I squared plus OA Y J squared. Okay, however you want to play with the notation. All right, and when you get done, there's our distances that we need. All right, now we can start finding the components of that, because we can start doing some simple breaking the components down. So let's find A of X is going to be the A, all right, and that's going to be times the ratio of our 800 millimeters over 1,000 millimeters. Okay, and we get an answer for that. Let me just go vertically down here. But before I go down there, so where did I get that from? 800's up here, so that's my x direction on the x-axis. And I have the hypotenuse of vector A is 1,000. Okay, so let's plug some numbers in. We know we're 800 newtons, and we're 800 millimeters over 1,000 millimeters. Okay, and the millimeters cancel out, leaves us with newtons, and we're going to wind up with 640. Okay, and it's positive because everything is there, and that's our our A of x. Okay, now find A of y. You should underline that. A of y is equal to A, and we're going to take the 600, which is the distance in the y direction of vector A, divided by 1,000. Okay, and we plug in the 800 newtons times 600 millimeters over 1,000 millimeters. Millimeters cancel out, and we're going to get an answer that is 480. Again, that's positive, okay, because I didn't have a negative direction, a negative distance in my ratio here. Okay, I think for simplicity's sake, I'm going to do a b of x over here, and that's b times the ratio of this is going to be 424. No, sorry, distance. I want my distances negative 500 over the 1060. Okay, and that will give it to me. Now, no, I want to do that a little differently. I want to make the negative b here because this vector is in the minus minus quadrant, or quad 3. Actually, I guess that's Roman. Okay, so with that, I'm going to be able to get my negative information I need here. Okay, anyway, so vector B was 424, negative 424 newtons, times the ratio of 500 over 1060. The millimeters cancel out, and we are going to get b of x is equal to a negative 224 newtons. Okay, and I'm going to go back over here and put a of y in there. And then if we do b of y, underline that, we're going to be still a negative b, but our ratio changes on our distances now. We're 900 millimeters over 1060. Okay, and then we get negative 424 and newtons, and we're looking at 900 millimeters over 1060. Those cancel out, and we're going to get a number that is equal to negative 360 n. Okay, and that's my b of y. Okay, do the same thing for C, and I think the best part here is this is a good place for you to practice this. I'm going to give you the answers to those. You try them out and see how you do it, but it works the same way. The only thing I will tell you is C, when we look at the component of the vector, C of x is a positive C because it's in the positive x negative, which is quadrant 4. Okay? And then we're going to do the ratios of the distances. So 480 over the 10, 20 millimeters. Okay? And then C of y is in the negative, so it's negative C times the 900 over 1020. Need another m over there, over 1020. Okay? And you can try those out. When you get it all done, you should get an answer here that is C of x is equal to 192. Okay? And C of y is equal to negative 360 newtons. Okay? Now, we could go find the angles for this, but this particular problem doesn't want you to do that. Okay? So we'll come back to that in another problem down the road, but just finding the components of this. Now, why is finding the components of these interesting? One last thing here, and this is kind of takes you into strength of materials, maybe into the design course down the road. But we can have three force vectors acting on a single pin at O. And we want to know what's the forces that are adding up in there to do things. So we know where this is, how this is going to act on the member itself. And if we take all this and we take the 640 newtons, add it to the 224 negative, 640 newtons of A of x plus the negative 224 newtons of B of x, and then the 192 of C of x, we're going to get a resultant in the R of x that'll take us down there. So just like we did the original problem here. Okay, we'll leave that there. You can come back to it and practice it, and I'm going to stop.